this is where we had reached last time. We found the eigenvectors, or the eigenvalues, I mean, of a matrix. We're going to find the eigenvectors now. Now let's look back at what's going on. You see this? We're going to rewrite it. But we need to put x on the right because we cannot have x being a 2 by 1 matrix multiply a 2 by 2 matrix where x is on the left. We have to put the 2 by 2 matrix on the left and the 2 by 1 on the right. So it's going to be a minus lambda I, x equals 0. It's going to be a minus lambda I. Let me rewrite the lambda. Lambda I x equals 0. Alright? Now, A was 3156. So we have 3156 minus lambda 1001 equals 0. No, times x. My. Times xy equals 0. So what we have is 3156 minus lambda 0, 0, lambda, all of this, times xy equals 0. Alright? Now, for lambda 1, we're going to work with lambda 1 equal 7.19 and see how things work out there. Now, this is going to be, if you simplify this further, you have 3 minus lambda, 1 minus 0, which is 1, 5 minus 0, which is 5, 6 minus lambda equals 0. So we can rewrite the round brackets now. So we have 3 minus 7.19, 1, 5, 6 minus 7.19 equals 0. Alright. Now, remember, here, this 0, I keep writing equals 0. I forgot that I was writing as matrices. So it's 0, 0, I should have written equals 0, 0. Right? Everything has matrices, not just number. It's all matrices here. So it's 0, 0, 0, 0. Alright. 3 minus 7.19, what is that? 3 minus 7.19 equals negative 4.19. So we have negative 4.19, 1, 5, and then 6 minus 7.19. So we have 6 minus 7.19 equals negative 1.19. Negative 1.19. Alright. Times. Oh my. Why did I forget to put the xy between? Why my xy? Yeah, the xy should be there. So it's this xy equals 0. Right. This times xy equals 0, 0. Okay. So So here now, if you say negative 4.19 times x plus 1y equals 0, you say 5x minus 1.19 y equals 0, right? Let's call this equation 1 and this equation 2. They should be the same, but let's divide equation 2 by 1.19 and see what happens. This will be 5 over 1.19x minus 1.19 over 1.19y equals 0. So 5 divided by 1.19. 5 over 1.19 equals 4.2x. So this gives us 4.2x minus y equals 0. Alright. So in this case, we have run out of scrolling space. Let's just do this part over here. For if we should multiply equation 1 by negative 1, we have 4.19x minus y equals 0. Equation 2 is a 4.2. It's just about 4.19, right? Because we're rounding off and so on. So 4.2 is a 4.2x minus y equals 0. Now 4.19 is just about 4.2, but there's a slight difference here because we're rounding off. So let's call this 4.19 just the same. So you see, they are the same. So both equations, as I expected, would be the same. So if we add y to both sides, we have 4.19x equals y. So y is equal to 4.19x. Now we can use that to find the eigenvector. What is the eigenvector here? Now, if we make x 1, then y is 4.19 by 1, which is 4.19. Right? But it's, it looks neater if we just say 4.2, close enough. So here, what we can say is and by the way, hold on, I had xy already. Since I label this as lambda 1, I'll just label these as x1, y1. Because when we come to lambda 2, we just call them x2, y2. This is x1, y1. Alright? So these are x1 and y1. We don't want to call these x and y, and then when we come to the next one, we still call it x and y. That would be technically improper. Alright? So here, when we have for lambda, what was it again? For lambda being 7.19. Let's draw a line up and continue working because we can't scroll down anymore. Let's draw a line upwards from here. What else is going on here? So when you have 7.19, it is 1, 4.2. So for lambda 1 equals 7.19, x equal 1, 4.2. Alright. Now, for lambda 2 equal, what was lambda 2 again? 1.81. The other one was 1.81. We want to find out what thing there is. So we use this formula again. 3 minus lambda 1, 5, 6 minus lambda. So 3 minus lambda 1, 5, 6 minus lambda. And then this had x1, y1 equals 0. Let's call it x2, y2 equals 0. 0, 0, right? Label them x1, y1 for lambda 1 and x2, y2 for lambda 2, right? Using x and finding x equal that and y equal that. And then in the same question, saying x equal something else and y equal something else, that would look out of place, right? Now, here, remember our lambda is 1.81, so we have 3 minus 1.81, 1, 5, 6 minus 1.81 by x2, y2 equals 0, 0. So what we have now? What is 3 minus 1.81? So we say 3 minus 1.81 equal, it's 1.19. So we have 1.19, 1, 5, 6 minus 1.81. So we have 6 minus 1.81 equal 4.19. Times x2, y2 equals 0, 0. Alright, multiplying out 1.19 x2 plus 1 y2 equals 0. And then 5x2 plus 4.19 y2 equals 0. Now we want to ensure that they are the same equation, so we have equation 1 and equation 2. Suppose we divide equation 2 by 4.19. What we're going to have is 5 over 4.19 x2 plus 4.19 over 4.19 y2 equals 0. And then 5 divided by 4.19. So 5 over 4.19 gives us 1.19. So we have 1.19 x2 plus y2 equals 0. Let's see. Alright, same thing. So they are the same. So what we do now is say y2 equal negative 1.19 x2. By the way, I keep seeing the 1.19 turn up. And I had said 4.2 looks neater than 4.19, but with all of these 0.19, let's make it 0.19 then, just for consistency throughout. It looks more uniform. So y2 is negative 1.19 x2. So that means if you have x2 being 1, you calculate what y2 is. Y2 would be negative 1.19 times 1, which is negative 1.19. Right? So we can say for, I will underline this Keep these things up here. For lambda 2 equals 1.81, this is x1, lambda 1 x1, x2 equals, it was 1, and what else? 1 and negative 1.19. 1 and negative 1.19. Okay, so those are the solutions to what we have here.